Hello guys, and welcome to another video from Arduino Studios. Today I'll be showing you how to make an easy to make snake game on an Arduino board. If you don't know what the snake game is, it's a game where you have to control a line, which is a snake, and eat the items, making the line grow in length, while at the same time avoiding obstacles such as the edge of the screen and the snake itself. Due to it being simple yet challenging, the game has been ported to almost, if not all, platforms. So today I'll make a port for an Arduino Nano board. To make it, you'll need the following materials and equipment: a breadboard, some jumper cables, a passive buzzer, 2 push buttons, 1 Max 7219 8x8 LED dot matrix module, 1 Arduino Nano, I use version 3, or compatible, and a mini B USB cable to upload the code, a computer with a USB port and the Arduino IDE, download link is down in the description, and of course, some motivation. The connections are as shown in the schematic, the image being downloadable from the link in the description. Now that the hardware has been assembled, you can begin coding. Start by launching the Arduino IDE on your computer. The code requires the MD-MAX72XX library. This is a very commonly used library, but if you don't have it, you need to get it. Go to Sketch, Include Library, Manage Libraries, then search for MD-MAX72XX, and get the one called MD-MAX72XX. Select version 2.10.0. After installing it to your computer, don't forget to include it in the code. First, we need to define the pin numbers. Since you connect the display pins to the Arduino's pins 13, 11, and 10, we need to specify so here. Then, we do the same for the buttons and the buzzer. This will make it easier in future if we decide to, for example, change the pins. I'm also defining some more numbers because they will be used later in the code. Type used most will be the struct because it makes the code tidier and cleaner. After declaring all the variables, we can then proceed to set the pin modes for each pin and then set the seed for the random function from an analog read from one of the floating pins. The biggest thing would be about how to store the snake's pixels positions as well as how to handle it. In here, I store each of the snake's pixels row and column positions in arrays. The head of the snake is in index 0 and it trails on until the end of the array. We print all the values onto the screen. But if that's all, then the snake will always be the maximum length. To get over this issue, we have another variable, length, whose job is to tell the Arduino when it should stop writing or reading from or to the array. As the snake grows, the length variable is incremented and we draw one more pixel on each successive loop. The main events in the program are the key patch detection, direction and food processing, then updating the display and sound. If a button is pressed, it decides which way to change the direction to. It also detects whether the snake has hit the item, called food here, or not, and what to do in both scenarios. Finally, once all processing has been done, it refreshes the display with all the new positions and plays the requested sounds. And once you've uploaded the code into the Arduino and waited a few seconds until the Arduino stopped blinking rapidly, the game is ready to play. And that concludes this video. Don't forget to subscribe, like, and a penny for your thoughts in the comments section below.